Nice to meet you. Thank you for inviting me. Thank you, Bogdan, for using my first slide. So if it goes wrong, I can put the responsibility on you. If it goes well, I take the credit. Okay. Now you won't see the notebook LM, right? So I did it. So this slide is just for me to show you that I've been in a lot of organizational cultures, different ones, European, global, local, state, private, and so on, which was very helpful for me. And the topic, SOC transformation in AR era, I want to know, I believe you all know about AI somehow, at least to write a prompt, but do you know about SOC?
Knowledge.
Okay. So for the other one, SOC it's Security Operations Center, right? It's like NOC, but with an S. And of course, in the era of AI, this is also needs transformation, and at the end of the presentation, we'll also know why. So my first question for you is, why do you think the current model is not enough? Since a few of you said you know what a SOC is.
Because they just can replace anything in the chain.
In what chain?
The entire SOC chain can be operated with the CM to so on.
Okay, that would be a benefit, but what is a drawback of the current model?
Well, they are all trained on previous data. So
They are not trained, they are human-led.
Okay, so if you say, well, okay.
The current model of the SOC, how the SOC is working right now. The classic SOC, the legacy one. Do you think, you know how many events or alerts SOC analysts have to take a look on a daily basis?
Million. So we
Not a million, but
we have a heartbeat of 60,000 hours, which is creating 1,000 events per day.
so it takes, we have 40% of the alerts that are getting through the SOC not investigating just because of not enough people and not enough resources, let's say, right? If we're talking about large enterprises, there are up to 3,000 alerts coming to the SOC.
At the day or 3,000 events a day?
Yeah, daily events. But average for smaller companies, it's lower, but for the bigger ones, there are 3,000 per day. And imagine if you're an MSSP, so if you deliver security services, you get alerts from all of your customers. And another problem is that they're not coming from a single source. They are coming from different type of documents that should be integrated with the tool that are receiving, usually the CM. What is a window of exposure? Is the time that from the beginning of an incident, of an attack, let's say, until you actually try to do something about it. And considering that it takes less than an hour for a phishing attack to actually infect your whole infrastructure, if you take a human to analyze that alert, it will take him, her, they, usually 70 minutes. Those are some averages from the reports. The main problem is, and probably also because of AI, that there are not enough humans in the SOC comparing to the number of alerts. Not only that, the AI is also used offensively, so the attack surface increases. And the other numbers or other problems, let's say, that you can think about, you're using cloud, right? Do you think something about cloud that can be an issue in this legacy model of analyzing the security incident? Not the companies don't usually buy all the features that will enable them to have all the logs, all the visibility in their cloud environments. So if you don't have visibility, then you cannot pinpoint that it's an actual incident, security incident or not. You might say it might be, so you don't take the correct decision. Another issue is that you cannot build, because you don't have this visibility, you cannot build a threshold, or like a baseline for what is correct, or what is normal, or what is not normal. It's all clear right now? You can ask me a question, because I try to not have a session at the end, but you can ask me. No.
Or if it's available, it's way too expensive. So if you ingest a lot of logs,
Yes.
it becomes a cost issue.
Exactly. Usually nowadays, not the companies, but the solution, the CM solution, they are usually you pay by the number of ingested events. So this is what we could miss, right? And what are the current model, let's say, problems or issues that we can solve? Maybe, we don't know, but we hope we solve with AI. Mm-hmm. So these are 4, let's say, stages that we can, where we can use AI in the SOC. And the first one, the autonomous triage. Now the triage, what is the triage? It's the decision that a SOC analyst does to say, okay, this I should look at, or this is not worth it, this is a false positive, right? That will be the biggest increase in the time spending if you use AI. Because if you train a model to discern, to determine if this is a false positive or not, then you have more than 50 or 60% of the events put aside, so the human can focus on what it's supposed to focus. The next phase is to increase the context, to give more context to the analyst, so they can take a better decision. Can you give me an example of a security event, let's say, that will make it to the SOC? How can this be enriched? So the AI can be trained to give more details to the human analyst in terms of, okay, this is the brute force attack because of, so add some reasoning, and this is how it came to, this is where it was, this was when it was first saw, in which system. So all this data can be delivered to the analyst to help him decide, okay, this is a true positive, I should move on investigating. So that's an example of the enrichment. Predictive detection is I think it will be very helpful in automotive, because you can create a baseline, what is normal, and actually can depend very much on the industry. That's why I said that in automotive, because you have a lot of telemetry data, you can you can construct a model with a good baseline, and then decide if it's an issue, a security issue or not, based on that baseline. And the genetic orchestration was the final phase, when you actually onboarded all the AI in your SOC, when you can teach or train an agent to take decision, like enable a firewall rule to block the traffic, or close a switch port, or maybe send a non-install or a quarantine to the EDRs to quarantine the specific file, and let the agent do that, of course, with specific guardrails, right?
How much of this transformation is driven by LLMs, by this change, like with the LLMs themselves, and by specifically trained models for security? Because I was under the impression that the security space benefited from AI before the LLM. So one of the applications of traditional, it's called the traditional AI models, neural networks and so on, was helping security before the LLM era. So how much of this is driven now by the LLMs versus purposely trained models for security? As in, for example, to understand traffic patterns.
Yeah.
Do you need an LLM for that, or you just build
If it's a
Train
specific,
the model.
if it's a
to understand
specific
it.
industry, a specific type of, let's say for the general IT infrastructure, not necessarily you can use the general one, but for specific industry, you should train your own one.
Okay.
In financial, they already did it with the Bloomberg AI. I think every industry that wants to be a leader should do the trainings on their specific data.
Okay. And that has changed now with the LLMs revolution? Or
Yes. I mean, I don't know what you mean by security had it before.
I mean, being able to catch security alerts pre-2021.
Yeah, well, it was done by static rules. So there was CM, there were some CM engineers that look at the rules. Okay, if I have the event like a login event from a Microsoft Windows system, and then I have a privileged user like admin, and then I have a lot of traffic going outside from that machine. These rules in a sequence, in an amount of time, would mean probably that there's information. But there were static rules predefined. There was no, reasoning or model.
Okay. And then just another one. You mentioned initially that one of the problems in SOC was the cost, the fact that you don't have, like, it's expensive to have all the logs and just store the data and so on. By doing this automation doesn't make things more expensive, because in order to make this work, you have to have the logs. And
The idea,
pay
yes.
for the logs plus.
No, you don't pay for the amount of logs that gets into the CM, because you use the AI earlier, before ingest them in the CM, to make the decision if this is worthy or not to go there. So the idea of this slide is that AI in the security, in the SOC, shouldn't replace the engineers, the SOC analysts, or the people working in SOC, but should help them, leverage those number of events to enable them to have more time for decision. Okay.
It's a theoretical thing that, okay, of course, everything is making us more productive since humanity is existing. I would say when we started with fire and stuff like that.
Yeah, security is a break.
So since then we have a productive, but here the amount of tank vectors, what we have, and the speed what is coming up requires a hell of investments of companies and secure that. And I think from a sovereignty perspective and from a brand perspective also, security becomes a real strategic asset to manage this. That's why I think it's not becoming cheaper if you mean that. I think the costs are going up. We need to consider that as a brand asset or a company asset to become that, and not at the end.
Yeah, actually,
the
what
software is launched, let's make some security on it, like we did it in the past. I think this is what this is about.
That's correct, and actually money wasn't on my next slide. What I'm understanding is that you don't need to scale the human that you need to hire in order to be able to keep up with all the new thing that you have to protect. And this is the one thing that AI augmentation will help the SOC.
My question would be more in the lines of, in the last couple of 1-2 years, most of the breaches that we had were based on credentials that were lost, and somehow the attacker also spoofed the location, like geolocation, and they got in, they didn't have anything to stop them pretty much, or figure out, even if they were using Microsoft Sentinel. Yeah,
Okay.
That's very much similar to what you mentioned before. And somehow those attacks keep going in the last months also. So how do we get to the point where we have zero trust, and that would also imply that how can we enable our organization to be able to be resilient against those kinds of attacks? Even when we use MFAs and cookie
It's not necessarily an answer related to the presentation, but to train your people to not reuse their password. That would be my first thing. Of course, also these breaches are going to the dark web. They are sold there, and another defensive vector is to monitor those forums, get inputs from what is published there, what announcements are done. Okay, we sell this data from this company or stuff like that, and ingest that into the CM so we can take decision. Okay, we have information that in this industry there's something. Not sure, but they don't usually show you the data when they sell it, but they say, okay, we have, and they give you some samples, so you can buy it if you want. But if you have a knowledge about this situation, you can input this information into the SOC defense. It's called threat intelligence, so you can use this to enhance your detection mechanism.
But I think you're right. This is a very interesting question. I mean, we know that the biggest threat in terms of cybersecurity is not a mistake or an exploit in code. It's the human being.
Yeah, but who made the code?
If you think about social engineering, how an AI is imitating certain things and the capability, and I guess these capabilities would improve.
Yeah.
If we are at a starting point there. Then it becomes very interesting how humans are going to manipulate it. And I think it's not done with training people, because the people are not recognizing anywhere what is truth and what is not truth. And I think that is really a challenge. That is really a challenge, because it's not the mistakes in code. What is threatened? It's the social engineering.
Mm-hmm.
And even since you can spoof cookies, for example, have a file that logs in on a browser, and there might be more information to be had. Maybe it has like a chat where you logs in like a password and so on. So yeah, that's a bit usual.
You have to agree or not?
And to put some pressure also on the software developers, the mistakes in codes happens because of humans, right? Or used to, because now they are.
So much purpose.
Yeah, I know.
If it's 25 years there, nobody is programming like 25 years. Yes, they agree this. It's if a model like mutuals comes out and we use it, offenses, they find the mistakes. The real threat are human beings, and when they are manipulated, especially in companies.
Yeah, but in the form that you put it, I'm afraid to say it because it's not politically correct. Okay. This is a comparison with the old, or not, the classic SOC KPIs and the new one when we have AI-enhanced SOC. We'll not look at the total arrests that we log, but we look at how many of the alerts we actually escalated because there are true incidents, true positives. We'll look at the mean time to contain and mean time to detect, not on the mean time to respond or how many analysts will we have as a head count, but how many hours did they work. So the measurements, the KPIs will change when you have AI. You mentioned at some point about the regulations, right? And I have a slide of that also. Actually, the next one, it's the small difference between the classic, let's say, enterprise SOC and what will be needed or what is needed in the automotive SOC when you get data also from vehicles, because you have a lot of other attack surfaces there, which before security was on the rise, nobody cared about those. But now, as the cars are getting more, let's say, software full, they become also an attack vector. So there's an increased number of events that may come from there to the SOC.
So the AIRA metric, it says true positive yield, which is Is this like a shorthand for something that's more complex, or are we looking specifically at just?
No, what is actually a security incident? Not a lot of noise which happens now because of those $3,000 per day that 2 people or 3 people or 5 people needs to look at.
What about the false negatives? Are those accounted? So things that a
So the undetected ones, those ones will be the ones that you don't know about. So you'll get into a breach when you find that you had a false negative.
Well, yes, but in general, I mean, before LLMs, you would be able to tune based on, like, you know, a corpus of data. You would be able to tune the statistical model to, like, for example, minimize false negatives.
Mm-hmm.
I was curious if you're using LLMs for this task, how you would be able to do the same thing. That's right.
Maybe there's a difference in the meaning of the true positive here. So in this table, the true positive means when the AI or the SOC analyst actually detected a real attack.
Okay, yes.
The false positive will be when it's alerted as an attack, but it's not.
Mm-hmm.
I mean, if we go further, you have to get the execution of the exploit or, let's say, the breach to realize that it was so it will be too late.
Fair enough. I mean, given not at obviously not at here for this time, not at runtime, you wouldn't be able to do that. But when for let's say classical statistical models, when training and you have the corpus of data, you could adjust these things. You could say, okay, I want more false positives, but I want to never miss.
Yeah, you can train that. You can put.
Yes, but how do you do that with LLM?
This is like regarding related to the previous one, regarding the difference between classic, let's say, an enterprise SOC and a vehicle SOC, right? Because here we have another other things to look at, and actually, this is the big thing that I think may help a company that are trying to grow a security service, security operations center service.
Well,
Because when you have this amount of data and so specific to your industry, and you get to use it in order to create your own models that you can use them in security, then that will be a baseline for you to be more competitive and also to selling it as a service. There are no other industry that can get this data, right? Other than automotive. The same way where, like, there's no other data that the pharma industry can get because they have specific data. And you mentioned regulatory. Yes, we need to make sure that we match all the regulations in the industry, but not only in the industry, but also the general ones like NIST, DORA, whatever we have in Europe. But of course, also the specific ones in automotive industry. What does it mean that we need to? I mean, this is also a drive for getting security onboarded, right? Because you need to be compliant. But the use of AI, so in my presentation, the use of AI here will also help you because it will, by having a help, you can get more straight data that, okay, if we're using this, we actually can show that we are compliant. So you don't have a human that needs to search, okay, we are compliant or not. You have an help with AI. As Bogdan said on his talk about the software development, there's no bandage like one switch on and off to apply this AI. You need to first apply it. You need to apply it iteratively. You need to use face. You need to, as you mentioned, with the code spec, we have the pain points that we need to. So we need to know them. We need to define them very well when you start with AI. Why? Because this will be put in the model and in the agent. Right. So first of all, know yourself. It's very similar with what Bogdan said, so you got the idea from the beginning. Only if you talk about software development, here we talk about adding AI to our SOC capabilities, but the principles are the same. Know exactly what the best you can with what metrics you want to look at, what we want to improve, right? That's the first phase. Then don't just put it there. Use it initially with using APIs, connect to the different models that might be out there. See the phase three. It's you'll run it for a couple of months, depending on how big the project is, maybe more, and then adjust it also during that time. And in the last phase would be to add an agentic power, let's say, to when you can enable autonomous agents. So not fully autonomous, but in a specific guardrails. You shouldn't do that. Like you shouldn't shut down, the CEO PC. So you can put guardrails, of course.
You run it, as you say, there in the monitoring mode.
I'm afraid to run a fully automated agent right now, because it happened with bigger companies. But yeah, the final target would be to have a fully autonomous.
When you run it in monitoring mode, it means that it runs from the human analysts and whatever resources it can find on the web, or whatever resources you put at its disposal. But how do you deal with your attack vectors in phase one?
Well, there's not really new, or not so many new attack vectors, right? One of the cases, let's say, would be the one that we discussed with a false negative, right? The ones that it doesn't know anything about it. But then when it happened, you'll feed him in, you won't catch that one. But based on what I'm saying is that you reduce the probability for this to happen, because you not only have the data input by what is already in the CM. So there are rules in the CM right now that say, okay, if you detect that and if you detect that in this phase, in this sequence, in this amount of time, this is suspicious. The autonomous thing will take the suspicious level to, let's say, we'll look at the suspicious levels, we'll decide to do an action like implement a firewall rule, or maybe isolate the host, or I don't know, quarantine the specific file. But besides these rules that will be learned, there will be some behavioral, let's say, of the traffic or of the events that are coming. So this behavior, let's say, that a human wouldn't be able to analyze it in real time in order to take a decision, and that would be the autonomous, let's say, benefit of the AI. For sure, it will not be 100% correct, but as you run it and have it more time, it will be better.
Yes, I'm just worried. I mean, in the model that you described, the monitoring mode seems to be limited, 1 to 2 months in there. You can run it for longer, you can run it with your...
The monitoring here refers to you as a human look at how it behaves and how it learns and what decision it makes. It doesn't mean it learns. In the monitoring mode, you actually let the model run, but you as a human with experience in SOC, let's say, you look and see what decision it would make and adjust those. Mm-hmm. That's the monitoring mode there, not the learning of the model. Presumably you have a model that is very good, let's say, or adaptable to the security elements, and you put it in the SOC where there are already rules of detection.
So what do you do when new models come like?
What do you mean by new model?
You said that you monitor a model, and you said that it is adaptable. However, the model is a model, and they get replaced periodically, they get updated.
In general, so when you put a new model for whatever system it's operating upon, you have kind of a baseline set of evaluations with some scores, and basically you kind of rerun those in whatever way with the new models, depending. So I don't know what would be kind of the criteria for the score, but this is how usually how you kind of operate
model deployment into an AI system in enterprise environments.
On the last slide was just what should be the drivers for a company to adopt this. But I'm looking at the clock and I know that there's another colleague that needs to fit in 15 minutes. So there's actually one more slide, but this is not important. Thank you.